I have mainly been working, I think, in 4 different careers, but always being concerned with the interaction of human beings and machines somehow. I started in controlled systems, then worked in document processing and documentation, then made a proposal for a networked information system on hypertext, which was interesting at the end of the 80s, and in fact was one of the 2, since the other one came from Tim Berners-Lee. And then we got together to work on one, which was his, because his was based on the internet. I'll come back on that later. And after, yeah, you see, technology, it doesn't really work very well. Later on, I spent some time having seen how difficult it is to put across a new concept. I became very interested in public communication, and that was my last career at CERN. Any of you have a touch screen phone or tablet on you? Right. I have here an object from 1972, which you can later come and have a look at, which is the prototype touchscreen. Okay? It also came out of CERN. So I salvaged this from a dustbin about 20 years ago, or 25 years ago, and I'm very glad I kept it, because I don't know if we still elsewhere have one. So you can come and have a look at that at the end of the talk. So that's one thing you can thank CERN for. Another thing you can thank CERN for is the LHC, and when people say, oh yeah, but the LHC, what uses it? Why do we pay so much for it? And blah, blah, blah. A subject in which we can go in the question section if you want. I say, well, the web was the first spin-off from the LHC, because the LHC actually showed us, the engineers and people who stayed at CERN, watching the physicists coming back and forth between their universities and CERN, showed us that they needed an automated library somewhere. And that is really at the origin of the web. So the web is the thing that is, in fact, already a result of the LHC. Okay, now, I already said that I worked at CERN, and I cannot resist quoting a journalist about 10 years ago, who, after I had shown him around and we went for coffee and so forth, and he said, this is really amazing, this place, right? Because here are people who changed their mind in the face of evidence. Yeah. And I thought, isn't that what you should normally do, right? Isn't that what people should do? And then later on, I found out that no, politicians, ideologists, and other people with weird beliefs don't seem to do that. It is something that kids do up until they're a certain age. After that, they lose this ability somehow, which is a pity. Anyway, remember that's, I think, one of the biggest characteristics of CERN. People here change their mind in the face of evidence. I will very briefly, well, maybe not briefly, but I will sketch a brief history of the web. And many of you will have heard that there were other people who did similar things before. And if you read the articles, at least until about a year or so ago, about previous attempts, they seem to stop at Vannevar Bush's article on how we might think, or how we may think, in the Atlantic Monthly of 1947, I think it was. But, and I am from Belgium, but unfortunately I didn't know until last year, there were other people. There was a guy who set up what he called the Mundaneum. And Of course, you see only women doing the work, but that was normal in those days, right? And one man, of course, was like that. His idea was to collect all the references to all the documents ever published all over the world, and therefore build a gigantic index that you see here, which Google is now sponsoring. Guess why? And he came to about 16 million index cards before he gave up. And he had other ideas as well. He thought, well, now that I have this index and I know that this or that book is available in some faraway library, I can actually do more. I can use the telephone and phone up that library. And if they have a camera installed and I switch my TV on, I can perhaps even look at the thing at a distance. There's no need for me to actually go there, right? Or I can listen to it via the radio or something like that. I can actually, I don't need to get at the physical object. I can probably organize it so that with the references, my Google, I can actually download the stuff via the web. So if this is not a vision that is equal to the web, I don't know. The guy in question was Paul Otlet. He worked in Brussels. He also, in 1918, thought that it was highly necessary to have something called the League of Nations, which unfortunately President Wilson refused to do in Brussels and then decided to do in Geneva. But these ideas came all out of this guy, and of course he did this well before Bush wrote about his index and so on. So there were many ideas before, right? And lots of people tinkered with these things, came to nothing, didn't have the technology, and so on and so forth. If you ever go through Mons in Belgium, don't forget to visit the Millennium Museum, where you can see much of the remaining collection. Let me, for those who might have to explain to family or friends, or maybe even to themselves, the difference between the web and the internet. First, we have the equivalent of the cables that connect the computers, which are the roads, so they are passive. And then on top of that, in order to use that between two different computers, you must have some protocol, some agreed way of using it. And in the case of the roads, that's of course the traffic signs, because obviously we all have to drive on the same side of the road and stop for red lights and that sort of stuff. Otherwise, the roads are useless. So that's the internet. It's empty, but it's the rules by which the computers communicate. And on top of that, you can then build services. The first ones, of course, were a file transfer and email, and then all of these things existed. We had chat, okay? Chat rooms and stuff existed well before the web. And then one day we say, okay, we want this parcel delivery of documents over the same internet, and that was called the World Wide Web. And now, of course, we have other things, and then we have also outgrowths that are somehow aberrations and do not belong to the internet at all, such as Skype and Facebook and Twitter and that sort of stuff. Let me also debunk some myths or fairy tales that you may have heard. The most often quoted is that the internet was developed by the US Army, and no, that's not true, although a part of the financing of the ARPANET came from the US defense budget, but the internet came later and linked not just the ARPANET. So the ARPANET is not the beginning of the internet, it's one of the elements of the internet. Another myth or tale you may have heard that, yes, but the software that came out of CERN was very primitive and it was text only and so forth. I come back on that a little bit later. No, actually, we had something that was much more advanced, but was so advanced that we couldn't give it away to people because they didn't have operating systems or machines that could handle it. And therefore, we made the line mode browser. And unfortunately, the line mode browser, in my opinion, is the worst decision that we ever made about the web. You will hear more negative things as time goes on. Because, well, but I'll end on a positive note anyway. The web spread extremely fast. That's something I have to always explain to journalists. Why did it spread so fast? And I said, no, it didn't. Because it was very slow. It took more than 5 years, and you didn't have to do anything. Because all you needed to do was download the browser. You didn't need to go anywhere, pay anything. It was much, much slower, comparatively speaking, than the spread of, say, the railways, where every tunnel had to be dug, every sleeper had to be laid, right? And there weren't any machines to do it. So compared to that, I think the web spread awfully slowly, but okay. Now, I said before that there were people like Paul Otley and others who thought about a unified information system. And it actually could happen only by getting together, converging 3 big technologies. That of the hypertext, which is the technology that says you got the link somewhere and you let in a document that's on your computer and you let the computer help you read that document, clarify it, follow links, do all sorts of other things. Hypertext, of course, is much more than just following links, but that's what the web has. The personal computer, of course, had to also become affordable and spread. Has anybody seen or tried to look at the 1968 demonstration by Doug Engelbart? Yes, a few. Okay. Well, those who haven't, tonight, just Google that, Engelbart 1968, and you'll find the video of that demonstration, and it is absolutely amazing. He has multi-windowing, he has video conferencing, hypertexts, the graphical interface, the mouse, everything. But he did it on a computer that would probably have filled this room. But he had the imagination to do that. And Doug died earlier this year, unfortunately, so another pioneer whose real opinions we can no longer probe. And then, of course, there was also the network, right? You had to have the network, and the network, of course, was something that was also almost everywhere, but owned by individual country monopolies. And that created a big problem because you could not really connect from one country to another. Now, the internet changed that, unfortunately, with probably the worst technology that could be imagined, but it did change it. And the internet protocols are also largely based on technology that Louis Pouzin used on his Cyclade network in France in the early 70s. So all these things came together, and so at the end of the 80s, the internet was everywhere. The personal computer was everywhere. Hypertext was being experimented with lots and lots of people. And I wrote a little proposal. Tim Berners-Lee wrote a little proposal. We were both at CERN, but we were in offices about a kilometer apart. Mine was down here somewhere, and his was up the hill. Okay, we got together. This is another anecdotal story that I'm not going to tell. And I decided to switch and to take up his proposal, which was not only worked out, but also was based on the internet. Now, people often say then, okay, fine, so the journalists especially, we want only one name, and we want one invention. We don't want all this fuzzy history. So, okay, it's Tim, but what is the invention? What if you look at the web and you say, well, that had been thought of decades before, and this is not new, and HTML is such rubbish compared to HTML, you might as well forget it. So what remains when you have taken away all the stuff that hadn't been thought about before? What is the thing that you are left with? And it is actually the structure of the URL. If there is anything that I would say was Tim's invention, it's the structure of the URL. It's the thing that says, we take a protocol, we target a certain server somewhere on the internet, and we give it this thing, the red stuff. And the red stuff is something that it will interpret. We don't have a clue, we don't care what it does with it, but that's what we give it, and we expect something in return. That idea of making it possible to address any bit of information in an open structure that had no limits, that is the core and the heart of the web. I'm going to also to mention a number of people who you have probably never heard of for the simple reason that they are just not mentioned enough. And one of the people who was really crucial in the whole project was Mike Sendall. Mike Sendall was Tim's boss at the time, and a friend of mine. I'm 8 years older, which explains a lot of things. And Mike one day came to me and said, I know that you're working on hypertexts and network documentation systems and so forth. This guy, Tim, said, oh yeah, I know him. I met him 10 years before in PS Division. He said, yeah, he gave me this thing, and I don't understand that. And I would like you to comment on it. And that's how I read Mike's well-annotated 14-page copy of Tim's proposal, which didn't even have the words World Wide Web in it. And I agreed that it was totally unintelligible to management. It was really very technical. But Mike understood that we had something there that was important, perhaps, because obviously we were all thinking about the LHC and how to build that and how to get funding for that and how to make it work, because the LHC is a very difficult machine with a lot of information. And of course, we were 25 years earlier, so the computing power was a lot less too. So we were also looking at all possible systems, not machines, systems for writing software, for developing our own software. Actually, in 2 weeks' time, I'm going to a Computing and High Energy Physics conference in Amsterdam, where there is a panel on, can physicists buy their own software? And I think the answer is already no, because machines like the LHC are unique. Detectors like Atlas are unique. There is nobody who writes software for it. So you will have to go and write it yourself. So we were looking at these systems, and one of the very, very interesting things was the next system, which had been developed by, developed is maybe not a good word, by Steve Jobs, who had left Apple. So in 1990, Tim and I wrote a joint proposal. We chose the name World Wide Web, and Mike said, okay, why don't you use the next system, which we need to evaluate and have a report on by the end of the year? Why don't you spend the year trying to implement the web on that, and then see what comes out? And at least, even if everything flops, at least we will have the evaluation of the next programming system. And so, yes, we had something which I call the system, because I can't call it a browser. The reason being that it wasn't a browser. It was a browser, editor, and server all in one. So you could look at pages and navigate, and then you could change them if they were your page, and make modifications. And it was just all one seamless system. The machine in question is actually in the globe. It is, to my mind, not very well displayed, but you can see it in the globe without the monitor. The disk that is lying next to it is an optical erasable optical disk, which contains the backup of the 1990 software, and we lost the disk. So if anybody of you knows where the disk is, right, I would like to hear. Now, how was it possible to develop this quite complex system in a matter of a few months with only 1.5 programmers on it? Well, here's another person you have never heard of. Or has anybody? Do you know who he is? No? It's Jean-Marie Hulot. Jean-Marie Hulot bought himself a Mac in the early 80s and started programming it and found it was very difficult. What he wanted was some object-oriented system where he could plonk the objects on the screen, connect them the way they should behave, you know, put a button there and say, if I click this button, then this should happen there, and so forth. He wanted a graphical way of building his programs, and he wrote the next step development system. Well, he wrote it for the Mac. And then Steve Jobs hired him away from Paris, and there's an anecdote about this, which I'm not going to tell. So what we got was Jean-Marie Hulot's system with which to develop the web. We didn't know that at the time. This is one of Tim's very early attempts at the system, whereby you can see that you had not only pages with styled text and so on and so forth, but you also had vector graphic images. In fact, the black and white image on the right there was used by CERN until a few years ago only. And it still has LEP in there instead of LHC, right? Because the LHC wasn't built, obviously. But yes, we had all that stuff. Unfortunately, we couldn't say, here, have a copy, look at, take it home, put it on your computer, work with it. No way, right? Because this system was just more than 10 years ahead of its time. Is anybody in the room who has actually used Objective-C on OS 10? No? You? Well, right. You probably have seen that here and there is, when an error comes up, it says NS something, right? And that NS, of course, stands for next step. I mean that, so the Apple OS 10 system is actually still that same system, down deep below. Oops, my microphone has a tendency of falling off. It's not unreliable technology. We did several demonstrations early on. This is one in San Antonio in Texas, and of course, each time we did that, we had to have somebody give us locally a next. In the case of San Antonio, I was very lucky because I also needed a connection to the internet. We were in a hotel. So this was 1991. The only way to get a connection was to have a modem with you and connect it to the telephone and then do a dial-up to a university because the internet was nowhere else than in the university. So you connected up to the university, dialed up, but you had to have an account at the university. So I remember not knowing where San Antonio was, landing at the airport, getting into the taxi and saying to the taxi chauffeur, does San Antonio have a university? And he says, yeah, 3. Which one do you want? And so I said, well, anyway, I went to Texas A&M, and I gate crashed the IT department there. And to my great stroke of luck, the first guy I meet there had a Next on his desk. Right? There were, at the time, maybe 10,000 in the world of them. So we immediately hit it off, and I installed the stuff, and he gave me an account, and so we had this demonstration. But we couldn't, and I repeat, we couldn't give it to anybody. So we made this horrible mistake of saying, okay, so we want something really stripped down to the absolute minimum. something that people can download via FTP from our server and can install in, say, half an hour or at most an afternoon, and that can work on any machine. Now, what can work on any machine? So you have to throw away fonts. You have to throw away the mouse. The mouse was still not everywhere. You have to throw away cursor control. You have to throw away color. You have to throw away underlining and boldface and all that sort of stuff. You even have to throw away proportional spacing. So what you get is 80 characters, monospaced font, 24 lines. The last line you don't use, so actually you got only 23 lines. And you get this type of thing. Oh, and no editing, of course. I mean, editing in such an environment, that was just absolutely not possible at all. So we threw all that stuff away, and that's what people saw. Now let me color it for you anyway. So it looked more or less like this. And the red-colored things in brackets follow the style of normal scientific paper references. And so what you did, if you wanted, say, to have more information about Geneva, which is link number 1, then at the bottom where it blinks, you typed 1, and you hit the return key, and then the line mode browser would actually go out, follow the link, and get you the other page. Now, this was a total disaster. It worked extremely well. And in fact, last week, it has been resuscitated from oblivion by a team of young, enthusiastic programmers who wanted to build an emulator for it. So probably very soon you can experience it for yourself on the web. But the thing is a disaster because this is what the very enthusiastic, very young, and I mean they were at least 18 years younger than I at the time, that's what they saw. And when they saw that, they said, oh, well, that's a cute idea, but we can do better. We can put in images, we can put in this, we can put in that, which, of course, we already had done. I mean, we already had it on the next, and we had vector graphics, but they never contacted us, went ahead and went off in all possible and impossible directions. And that, I think, cost us at least 5 years in the deployment of the web, because, among other things, this was also what was picked up by Netscape. No editing, put in GIF images, but no editing, no vector graphics, no this, no that. Well, one single window. So really bad. We made other huge mistakes. Okay? I mean, I'm not here confessing to all of our mistakes. I'm going to become positive as well later on. But I remember a standing discussion, shall I say, shouting match in the corridors of Building 1. If I'm not mistaken, Building 1 is out there. No, it's out there. If you go to Building 1 after the lecture and go down to the ground floor in the corridor there, you will see the offices where we worked and the corridor in which this discussion took place. I said, we need a programming language here because HTML is not sufficient, styling is not sufficient. You need to have control over what's going on in the page. And the answer from all these 18 years younger hackers was never. Everything has to be declarative. We will never have a programming language. Now, you know also, as well as I do and as the previous speaker said, nature abhors a vacuum. So if you leave a gap, you leave a vacuum, then usually junk creeps in. And so today we have all these totally aberrational programming languages. I mean, there is no other word for them. These things work, but their syntax and their definition is just below everything. I have never seen such bad stuff as JavaScript. Right? I mean, JavaScript well, whatever. I got a similar reaction on my request for strict browsers. I'm not going to go into that because otherwise we're going to run out of time. And more than 20 years later, the consortium still hasn't decided on a video format, right? Well, Now, one of the positive things that did happen, and I'm quite proud to say that it was mainly my work, was to say, okay, well, in order to spread it, we must ensure that nobody feels uncertain about being sued for something. So we'll put this in the public domain. And on the 30th of April 1993, so that's 20 years ago, some CERN directors signed this paper which put the CERN software into the public domain and relinquished all intellectual property. They also added a clause, this is no precedent for other CERN software. And in fact, the next year they changed the general CERN policy. But that software of '93 was put in the public domain, and that made it possible for anybody to download it, play with it, modify it, and start working. This is the famous corridor in Building 1 that I think you should visit. It shows very clearly that people at CERN are not attached to what their working environment really looks like. The offices did look like that. I mean, it's the one in which Tim sat at the time. I didn't make this up. I didn't rearrange that. This is a real photo. And let me just summarize the role of CERN in the creation of the web. So in 1989, we had the first proposal, which was called World Wide Web. Which was not called World Wide Web. And then there was a new one in 1990, which was called World Wide Web. And that's also when the first software was available. In 1993, we put the stuff in the public domain. And I also flew about twice a month to Brussels at the prices of airplanes at the time in '93. It wasn't EasyJet, I can tell you, to discuss with the European Commission and to sort of show them that this was a really important thing. I sort of more or less succeeded. In '94, I thought, well, end of '93, but the conference took place in '94, I thought we must get all these very young hackers together. They have never seen each other. They have never had a beer together. They have just sent some weird emails and pieces of code, but they should get together. That conference series is still running. And then I spent 2 hellish years of my life helping to get the web consortium off the ground, and especially out of CERN. Because what do we do here? We do physics. We don't do engineering. I mean, I'm an engineer, but I was here for support of the physicists. We do physics. And the web was clearly not a thing that we could hold on to. We had to give it out. And that meant out of CERN, so that it needed another head. Now, officially, Tim was the director of the consortium, but neither Tim nor I were real people managers. We were geeks, you know. We still are, I think. So here is another person whose influence was absolutely paramount in getting the web off the ground. It's Jean-François Abramatic. He left his post of Director of Development of the Institut National pour la Recherche en Informatique et Automatique in France, and went for 2 years to work with Tim and the kids, as I called them. I think I had it right. I mean, I was so much older. At MIT to keep the consortium going, right? And it did, in the end, succeed. I was sometimes desperate, but Jean-François was always optimistic, and he was very good. Now, there were other things out there, you know. There were technologies that were not just similar to the web. They were, I would have said, far superior to the web at the time. So why did the web make it and not one of those? That is because none of those, however good they were, because of their structure, none of those could actually scale up, right? Hyperwave, for example, insisted on keeping all the links working. So there was never an error for a page not found. But the price to pay for that was that it could grow to about the size of a university. And after that, it broke down. So the web being just stupid and elemental and very forgiving, or unforgiving, depending on which side you want to look at it, could grow to any size. And that is what really made it break through. You can read all this to much greater detail in the book that James Gillis wrote. My name is on it as well, but he wrote 95 or 99% of it. So you can buy it downstairs. I have no royalties on it, so I'm not making a publicity for myself here. So much for the history of the web. Perhaps a little bit about how the web evolved in time. Well, originally, what we wanted was these servers, which are kind of treasure chests with stuff in it, and have them linked with lots of links. That works, but after a very short while, you find that it is very difficult to find things because you have to make many, many hops before you find what you want. And so something unscalable happened. We got the search engine. There were many of them. The first search engine ever was in '93, and it ran at the Centre Informatique Universitaire in Geneva. And then came other ones, and there came quite a few, and Alta Vista came, and then finally Google came, and Google, of course, bulldozed everything. A database is a centralized thing. Google is something that does not scale. There will come a point in time where there is so much information in the web that Google will fail. But we haven't reached that, and apparently not by a long while. So maybe there is only very little information in the web so far. Right? But it will, because it can't scale. And then another thing happened. These little walled gardens came up, the things that Tim was especially afraid of. Places where people go and stay and reinforce their prejudices. Things like Facebook. Right? And of course, the search engine has not as good access, shall we say, to what's in there. And of course, those walled gardens are not really part of the web. Right? And when I got very annoyed recently with the BBC, because they now say, well, if you want to give us comments, put the comments on our Facebook page. But I don't want to go there. I don't want to have a Facebook identity. This is just, So how can you rely on, think about it. How can you rely on a commercial thing that's not even inside your legal space, with which you have no contract? Because all you can do is click on the accept button or the agree button, right? You can't do anything else. You have no contract with these guys. And that brings me to another, alas, negative aspect. All these social networks, except perhaps LinkedIn, are based on advertising. That's how they get their revenue. Right? The client of these people is the advertiser. It's not you. You are the product. Right? You are what they sell to the advertiser. You're the product that they sell. And you have no contract with them. So think about these problems, because I think these things will have to change. And the failure, of course, of the web of not having a payment system means that this is now so well known that that is almost the business model you have to follow. There are several problems of global networks, whatever they would be. We have problems of transferring money, payments, and authentication that goes with it. We have, of course, all the other stuff that is undesirable in some way or another. I think the pornography part is probably the least bad one. The bullying of people and publishing of bad photos of people without their agreement is much worse. It's also used for extremist propaganda and terrorism. And you know, because the internet was developed for an academic slice of society, where there is a fairly civilized behavior. You know, as long as the internet was purely between the universities and the research centers, there was no spam, right? You didn't send people spam. It just didn't exist. So when this came available to the general population, all sorts of crazy things happened. And all the inherently unpluggable holes in the internet became used. I mean, nobody thought in academia of falsifying an IP number or of proxy servers or things like that. I mean, it was just, it had no function. But of course, when you get these guys, and especially the hackers, then all of these holes become very exploitable. So maybe we should throw the whole internet away and do something else, reinvent a completely different protocol that has all these holes plugged. I don't think it's possible. There are some positive things, and I will end with those. Of course, I like the web, right? I mean, I use it all the time. There are some very nice things. Has anybody here used Kickstarter? Whoops, no, not you. It was just a balloon going up. That is negative energy, I think, or something like that, because it should normally sink, no? According to the previous speaker, whatever. So these things are very good. The web has also made the whole internet visible, so that suddenly electronic mail and the speed of communication became available to everybody, or to most people. The search engine lets you indeed find things, whichever one you use, so that is really very good, but think of the scaling problem. And of course we have e-commerce, which also, when I saw it the first time, I thought, could go on for another hour about that. But you do have access now to some goods that can be sold only to very few people, and you cannot even go downtown to find them because you won't find a shop there. You will have to do it via the internet. That is an access you didn't have before. And perhaps the most positive thing is that sparse communities like people with rare diseases, people working on very specialized projects, they can now find each other, which was not possible before. Okay, so much about that. I will terminate by 2 or 3 words about the nature of computing. Yes, I have a few more minutes. Well, and the reason I want to do that is because you have to think about where the web is trying to go, where the whole of the internet and everything that happens on there is trying to go, where the whole invasion of computing in our lives is going or trying to go or whatever. And when I say, yeah, but you know, there's this and that, and I don't like such and such, and what happens here? And they say, oh yeah, but you're old, you know, you should see the kids. They just play with that. They sail through all these problems. They don't have this stuff. Well, I do not believe it's a generation problem at all. Okay? And the reason I don't believe it's a generation problem is that, yes, I agree. All these kids, including my granddaughter who has her own iPad and is 4 years old, all these kids know exactly what to do. They know very well which buttons to press, right? It does not mean that they understand what's going on behind there, right? Not at all. So I think the number of people who understand what's going on is very small, and I'm not sure I'm one of them. Although I have been down in the basement of the internet and sort of seen all the works, I still am not sure that I understand anything whatsoever about the interaction of these things with our human brains. So that is the important thing to think about. And it is exemplified by what happened on, was it Monday? When was the 23rd? It was Monday, I think. There was this eraser bill. Anybody heard about it in California? That said, okay, this is intolerable. There's all these teenagers publishing photos of when they are drunk or half naked and post them on Facebook, and then they regret it. There has to be a way for them, legally provided, must be provided, a way for them to get rid of these things and take them off again. Well, you can't take them off, right? I mean, you can take them off this site, but by that time, they may have been copied, archived, redistributed, I don't know what. So the guys who thought this up have no clue how this thing works. I wonder if they have an email, right? And what even appalled me more, and these are quotes from an article on, I'm not sure whether it was The Guardian or the BBC, but how can this guy say that this is a really important step forward? Nothing has happened whatsoever, right? And at least one guy commented on this. Yeah, it can't have been the BBC because somebody could write comments and I could see them, so it wasn't on Facebook. One of these guys wrote, well, yeah, you know, he was an American. Well, yeah, you know, a law that applies only in one state is probably not enforceable. Did he maybe think that if the law applied over all 50 states of the US, it would be enforceable? As if WikiLeaks couldn't, in 1 hour, set up a mirror server in Switzerland? I mean, what cloud are these guys living on? Right? So we really, really have not understood the nature of the digital world, and that's my last slide. First law of informatics. You cannot transpose anything, any idea from the physical world to the digital world, because the nature of these two things is so fundamentally different. Let me give you a few aspects. If you have one, if you think of one that's not on this list, I'll be happy to hear it. Anything physical is relatively difficult to copy. Okay? It requires energy, time, effort, and so forth. Digital copy is, you know, in some cases you don't even press a button. Okay? Google comes into your machine now and does its own thing, and you can't refuse it unless you refuse all of their services. The physical stuff is visible, right? I mean, I know there is something here. Right? The clock, the software clock that ticks in this machine, I can't see it. I mean, you can open the hard disk. This machine still has a hard disk, or the memory or whatever. You can't see it. No way. Physical things are also very simple. The tea kettle with which you boil your water is a very simple object. I know of nothing in informatics that is simple. Right? There isn't a useful program with one line of code. Actually, no, I can show you one. Physical objects have not much state. Your tea kettle is on or off, and that's it, right? When I go home with this machine, I will have with it the list of all the exact times to the second that I clicked on these slides, so that I can analyze them at home and say, oh, well, I spent too much time on this one and not enough time on that one, and so forth. So when I close this machine, it will have something new in it that wasn't there when I opened it a few minutes ago. Oops, I'm off the thing here. There's also very little need for an interface. You know, you don't need to explain the tea kettle. It has one button on it. I mean, you can drive it. You can rent a car and drive it. Right? You cannot go to another town and rent a machine that doesn't have an identical operating system to that you used, because you would be completely lost. A lot of interoperability is needed, and if the consortium had one great success, it was in establishing the standards for interoperability between the servers and the browsers. But this is something that you don't really need in your real physical life. You know, you don't need the engine of your car to be compatible with the body of your neighbor's car. It just doesn't, I mean, it makes no sense, right? And the physical world tends to distribute stuff. And the digital world, unfortunately, tends to centralize everything. So if you put up a social network site, then either you get everybody or you get nobody. Right? If you put up a good search engine, you get everybody or you get nobody. You don't want to have to search in 5 different search engines. This thing affects our brains. So the whole right-hand column is because it's the problem is in here. Or maybe it's only me, I don't know. So much for that, and I will end here and show you the T-shirts that we walked around with, but unfortunately I haven't got a real copy left. We had this slogan in the very early years, you know, let's share what we know, because that was really the main purpose of the web. Thank you. Any questions? Yes.
I think I might have something for your list.
Okay.
And to put it simply, predictable. The physical world, it's, at least you might have something very complicated like a watch or something like this, but in the end it's not that hard to predict. But a program, it might not be even predictable at all, no matter what we do.
Oh, yeah.
So
yeah, well, that's a good one. I'll add that.
This is why we can make a perfect antivirus, for example, because we don't know what a program
exactly.
does.
Yeah, very, very good point. I think the word predictable might not be, but we can discuss about it. But yes, good point, and I'll add it to the list. And are you mathematically inclined? Are you a programmer? You're a mathematician.
But working in IT industry.
Oh, well, very good. I have an interesting problem. I think I've solved that, but I'm not sure. It has to do with railways, but we'll see each other afterwards. Anybody else? Yes.
You said that a search engine like Google was not scalable. Do you mean that eventually it will collapse, or that it wouldn't be an efficient way to find information on the web?
It would gradually get slower and slower, take more and more time, because it has to look everywhere. Now, there have been technologies deployed to do the search in parallel and so on and so forth, but you can, and of course, the thing has been duplicated, right? I mean, there are copies of it. And then you can also apply a lot of other tricks, like you can say, oh, well, this guy has typed his search in German, so I'm not going to look at the English pages first, right? And things like that. So there are tricks you can do. But in the end, it's just not scalable. It has to be all in one place. And so there will come some time. But I think we're still far off. I hope. Yes, yeah.
Thank you very much for the most interesting presentation. Now the question would be, what is CERN's involvement today in the shaping of the future of the web or the grid? Or how do you, it may be a topic for a different presentation, of course, but maybe in a couple of words.
Well, okay. Let me first say that I retired from CERN 2007, so some years ago. I have, by the way, the web was never really located in IT, but that's not a matter. I don't know anything about the grid, because that came when I was already in public communication. And it was also very physics specific. CERN was certainly a member of the Web Consortium for many, many years. And I think it still is, but I'm not sure. So I'm not going to venture to answer your question, because the membership of the consortium has to be paid for, and I don't know who would do this. I can't answer that question. I think after the consortium was founded in 1995, CERN's involvement in driving the web went from 100% to nil in the matter of 1 year. I mean, I was still very much involved because I was here. CERN was a member of the consortium, but all the youngsters, the kids that were 18, 20 years old, younger than I was, they had all left, you know. Stig Nielsen, Adi Luoten, he'd gone even earlier. They were, you know, Håkan Lee, they'd all gone. And they were never really CERN staff members. They were there only for a few years. So it was a successful transfer of the whole technology from CERN to the consortium. Okay, of course, CERN remained interested. And for a long while, I did the CERN public web server. That was another long story. Which, of course, tried as much as possible to follow all the recommendations and standards of the consortium for good reasons. But that's about the answer I can give you. I think I have to stop because the next speaker is going to be, oh, where is he? Michelangelo? Not here yet? Okay. Anybody else then? No, one last one? No? That's it? Good? Oh, yes?
What was the internet before the web? I don't really imagine.
You're too young, huh?
Yes.
Well, maybe the thing to do would be to go back to this slide here, and say, you know, the very first thing you did with the network was to, and that was also the objective of it, was to use a more powerful computer than your university had, or maybe maybe just a computer that your university just didn't have, right? Distant. I certainly did that through telecommunications lines. And so what you then had to do is you had to log into this other machine. So you had a remote terminal, yeah? Which was called a terminal. Those programs had to be standardized over the internet, and they were called telnet, right? It's just a thing whereby you type an IP number and you log in, and then you have control of that machine. So you have to have a username, a password, and you have to have full knowledge of how that operating system on the other side works. And then you can work with that machine, but then, of course, the first thing you need to do is to transfer your data from your place to their place and transfer the results back. So the next protocol that was then developed was file transfer, FTP. It still exists, right? And then after that, you want to transfer a file and nothing happens. So what do? You call up the guy and the operator on the other side and say, "What, is your computer down or what?" And he says, "Yes, this was scheduled 3 weeks ago. We planned this," right? So you want email to inform your customers, or your users, rather, not your customers, but your users. And so one of these things just came one after the other. And in the end, you think, but there's lots of documents there. I want to look at them. You can do that more or less with FTP. You could do it with Gopher and so forth. And the web was sort of a way to say, this thing we publish for free for everybody, without login, without anything. And the rest, well, that's more private. And that was the original idea of the web. But we had chat, for example. You know, we could do what you do with, I don't know, Skype or SMS. That was all there. It's not in this slide. Okay, I have to leave the room to the next speaker. Thank you very much.